Hi guys, I welcome you to the day 15 of the training today. I'm happy that all of you have made this far, and I hope you are learning every day a new thing in Verilog HDL or in the FPGA development. How do we design the architectures and how do we implement the design through hardware language? So it's a description language, as we all know. So now what we are discussing these days, from the day before yesterday and today. So all these classes are related to how to write the core part of the Verilog HDL. Means the process, actually how the structure of Verilog HDL should be written. So in that we have three types of modeling. One is gate level modeling from the circuit diagrams, from the logic circuits that are connected. From those designs we will be writing Verilog HDL. And the second one is data flow modeling that comes with the Boolean equation. With the development of Boolean equation, we will be writing a Verilog HDL based on the functionality of the Boolean equation. That's the reason we also use operators according to the Boolean equation, because in Boolean equation, you all know an equation consists of operators like arithmetic operators, relational operators, logical operators. So based on that, we will be writing Verilog HDL. Then after completing data flow model yesterday in the day 14 of the class, in today's class we will be discussing about behavioral modeling and what is behavioral modeling and some examples in developing behavioral modeling. There is a continuation for this lecture as well, so please follow us. I mean, stay tuned to the updates so that you will be completing the behavioral modeling as well without any pendings. I mean, you don't miss the flow. Then coming to the today's agenda, behavioral modeling attributes and examples were discussed, like as we have discussed with gate level modeling and data flow modeling attributes. Attributes are nothing but properties of behavioral modeling. What is the syntax and what are the examples and what are the blocks available, what set of rules that we need to follow. So if you are writing Verilog HDL and describing the architecture on FPGA, then you need to write the code in behavioral modeling. Why we should be writing? Because it says the behavior of the architecture. Based on that, EDA tools will be understanding the behavior of you have written in the Verilog HDL. Then it makes a sense of connecting the set of logic cells or AND or some group of multiplexers, and it makes some architecture with on the hardware. So that makes synthesis part. But before that, in Verilog HDL, if we write behavioral modeling, that itself we are designing the hardware architecture. So our main aim is to derive a hardware design. So that's what behavioral modeling helps with. And most of the times 95% of the Verilog HDL codes in the chip designs will be in the behavioral modeling. Only 5% or 4% will be around data flow modeling, and here and there we'll be talking about gate level modeling. I'll try to recap that gate level modeling as well, but now onwards your focus should be in the behavioral modeling. What is behavioral modeling? It is a type of structure of Verilog HDL code that we need to write, we need to follow always. So every time. So then coming to the procedural blocks, and then we have blocking and non-blocking assignment statements in the procedural blocks. For example, what is blocking and what is non-blocking assignment? Assignment is nothing but this is equal to and this is less than equal to symbol. That's just a symbol description. I'll give an example of how it will be looking like. And then we have if else and case statements. Um, what is the application of if else and case statements? Like in the C programming, if we are designing the hardware architecture, we should be designing a group of circuits. Those circuits can be designed once and made them in a loop of the design. So if you have designed once and if you create a loop of that design for next 100 times for the next 100 circuits, so these kind of if else and case statements will be helping you to design 100 logic circuits, circuit connections within one single loop. So that helps the ease of the thing. And other advantages, if else and case statements uh, are only the statements or the loops that can be used for synthesizing. Synthesizing is nothing but hardware purpose, and all other loops like for or while, those cannot be synthesized. Synthesized is nothing but whatever you write the architecture, that can be transferred to a hardware description. So if you write some if else statement, that can be turned into OR gate or AND gate. In that way you can derive it. But if you are writing for loop, yeah, this is also useful. We will be using as per its convenience. But for the for loop, we cannot synthesize a logic circuit like whatever statements. For example, if a plus b is, if there is a condition, if a plus b means a and b together OR gate. In this way OR can be declared as this. But for the condition or the initialization or the control statement, I mean increment or decrement, cannot be turned into a logic circuit. I will explain this in the later classes as well, why for loop and why while loops or any other loops are not synthesizable. That might be a question. So for that I will be answering soon. But now today we will be discussing about behavioral modeling, procedural blocks. What are procedural blocks in the behavioral modeling? Very simple. You already have seen that in the Verilog HDL programming since the day 6 or 7. Now we are actually understanding why do we need to write initial or why do we need to write always. Those kind of terminologies we will be understanding. So follow along. So going to the next topic, behavioral modeling introduction. So let us know what is behavioral modeling. It is developed based on the functionality of the design. Functionality, how do we get the functionality of the design? By the truth table. I'll show you an example in the next topic. So, and nowadays most of the Verilog HDL programming is developed in the behavioral modeling, and Verilog HDL in behavioral modeling can be similar to the syntax of C language. That is another advantage. Whatever we write in the C programming, if we know the basics of C programming, that itself will help in the Verilog HDL development. And also the constraints, we can declare the constraints in an understandable way. But while writing the hardware description language, the major advantage is it will be helpful to understand what we are writing and what are the lines that we are going to execute. So behavioral modeling has many more elements, like what are the blocks called as, I mean, procedural blocks. As I have already explained while writing Verilog HDL, think of parts. What are the parts available? And based on those parts, you can declare, okay, first part should be module name, second part should be input and output. In the same way, while writing behavioral modeling, we have internal blocks and also some blocking and non-blocking assignment statements. Also, we discuss about loops. So let us go to the next slide. Let us take an example of 2x1 multiplexer. In the 2x1 multiplexer, code will be in this way, but when you see an element, 2x1 multiplexer should be written. Take it as 2x1 multiplexer truth table, and then write down what do you have as inputs and output. These are inputs. Got it, guys? So understand between input and output. So when you have selection one selection input, so it is 2 by 1 mux, right? Two inputs means 2 power 1, so n number of selection inputs. As I said earlier, if it is 4 by 1, if it is 4 by 1, then it has 2 power 2 inputs. 2 power 2 inputs. Then how many selection inputs we have? 2 inputs. So these are the selection. Understood? So in this way, you should be differing. I mean, you should get the truth table out of the element that you want to write. So once you get the truth table understanding, when selection is s is equal to 0, y will be following d0. Output will be input. When s is equal to 0 again, y will be value same as d0. I mean, when s is 0, d0 is selected. When s is 1, d1 is selected. So s is 1, d1 is selected. So when s is equal to 1, d1 output, d1 is an output. So in the same way it is related here. Got it, guys? So in this way, now let us write Verilog HDL code. So how do we write? First part, mention name. While I am explaining, you can also write without seeing this thing. By understanding, okay, we have inputs and outputs. This should be the functionality. If s is equal to 0, then y is equal to d1. If s is equal to 1, what this says, it says s is equal to 1. We can write in this way, or if we don't write in this way, the default value can be 1. So that is condition. If else conditions and syntax in the if else will be also explained in this training, in today's training. So first part, understand, it is first part. You declare module name and inputs and output. Okay, so inputs and output. Then after we need to declare about input and output. That is second part. Understand, first step, second step, and this is third step. Third step is always continue, always at the rate. So why do we write always continuity statement? So this statement is very important in behavioral modeling. Why do we write? So we write because after this always at the rate, we are declaring that, okay, for Verilog HDL that we are writing, you need to begin the process from this always. So whenever you see a change in input value d0, d1 or s, if you see any value changes from 0 to 1 or 1 to 0, for every transition of the data change, the entire process will be beginning. That's what always at the rate inputs, or always at the rate, sometimes we write pause edge of the clock. If you are writing group of modules in a single big Verilog HDL compiled file, then we also declare clock for sequential circuits. In the sequential circuits, if you declare input as one input as clock, then you can say for every passage of the clock, the data or the process should be changing. So what we are declaring now, process are this is process. So again, we should begin this. This is step 4, begin, and then LRS, guys. 1 second. So condition is 5. we need to end this. So ending is nothing but again related to step 4. I am mentioning it as step 4 again. So when you write begin, write end. Definitely, if you start with begin, write end. Then after, between begin and end, you need to declare the process. So fifth step is process. Remember how I am making you write, understand. So first step is declaring module and name. Second step is always input wires and output registers you can declare. I have declared wires and registers in this way. Sometimes I will declare input as this and wire as D0, and I will write individually, but here I have declared in this way. Then after, third step is we need to say that Verilog HDL, or for the EDA tool in the architecture, for every change of the value you need to continue the process. So that declares with always. So always at the rate D0, D1 or S. Then begin, no, begin, we need to begin and end the process. So that is step 4. What is the process? It relies in the functionality. This functionality can be derived with if else or case statements or some of the loop conditions. But if S is enabled, 1 means enabled, 0 means disabled. So if S, that means enabled, output will be input from the D1. So imagine this as mux, 2 by 1 mux, and you only have one selection, and this is D1 and this is D0. Then you have output. So I am explaining this statement. If S means, you can say if S is equal to 1. So if S is equal to 1, what is the input? D1 will be the input. So data, whatever data is there, that will be transferred to the Y. So Y is equal to D1. That's what we are telling. So again, in the equal to operator, whatever data is there, that will be drawn to the D1. I'll write it in new format. So whatever data you have, that will be given to the Y. And else means other than this state, if S is not equal to 1, that means S is equal to 0, I mean disabled. So if S is equal to 0, the data will be selected this D0, and whatever data you have in the D0, that will be sent to Y. So Y is equal to D0. Usually we can also write from if S is equal to 0, and then Y is equal to D0, else Y is equal to D1. In that way we can write, but it is a simple notation that can be helpful. Why do we write in some shortcuts sometimes in Verilog HDL? Because every character has some size, and every character, if you increase some operators and characters, right, there will be some sort of syntax error. So to avoid those things, we will be declaring in very simple shortcut. So these kind of shortcuts. Got it, guys? So D0 and now understand, this is how you write behavioral modeling. Same steps. Every time you declare module name in input and outputs, always continuity, begin, and then if you write begin, write end immediately, and then we need to declare the process. So this process block, this process can be written with the definition of functions or definition by loops. So this is one loop statement depending on the condition. If this, go to this, and else go to this. Understand? So this is again the last step is end module. This will be related to the beginning of the module. So when you write module, you can also write end module, and between this module and end module you can write all these things. That is the good way of practice. You will not forget the end module then. So coming to the next, what are the elements of behavioral modeling, like attributes that are properties again. So first elements are major elements in the behavioral modeling are, we can see that we have initial block and always block. So what do we get from initial block and always block? That's nothing but when you write Verilog HDL in this structure, right? So this is always block. So always block will be executed for every single chain. So it is a continuous execution. Continuous execution. Continuous execution. But initial block, here we didn't declare, but in the initial block, it will be like only one time. So you begin the process, that is a one step, starting of the entire process. So initial block is the starting of the program and executing only once in the beginning. That executes only once, initial block. So whatever block should be starting in the initial stage, like if you want to start the process, that should be your initial block. Then after, whatever the always block you have, that should be like continuous change. So for example, loops. So always block is where the process or program loop is executed continuously as per the change of the input, data at the rate posage or clock at the rate inputs. That's what we have declared here, always at the rate. So I'll be showing with examples as well. Understand, in behavioral modeling we have two blocks, initial and always block. Those are always called procedural blocks. This is must and important thing to remember. If someone asks what are procedural blocks in Verilog HDL, okay, we do get procedural blocks like initial and always block. So if you remember these as it is, while we are doing some projects in the next session, we will be declaring these initial and always block, and you will be understanding when we do a bigger project like memory designs and all. In that, when we write behavioral modeling Verilog HDL, you can understand easily that okay, procedural blocks, okay, we are writing initial block first and then always block comes. In that way you can recollect and remember that. So yeah, we have two blocks. While you see the Verilog HDL programming in this way, you can understand. So yeah, other things, procedural blocks, uh, I'm explaining about procedural blocks again. So I have just given there are two types of procedural blocks, initial block and always block. So for that, what are the properties of procedural blocks? What do we need to follow? All the assignment statements are written in procedural blocks. You can declare them in the procedural blocks. So assignment statements like we have assigned something, right? And assign one example from the yesterday's thing, like if we have 4x1 multiplexer, we can assign concatenation, sorry, concatenation S0 comma S1. Okay, so this is how you can assign. So these type of assignment statements, and also equal to, and sometimes you can also write these type of assignment statements. This is non-blocking assignment, and equal to is an blocking assignment. Why do we call blocking and non-blocking? That I will explain in the later, in this next slides. But don't get confused. All these type of assignments are we can assign A is equal to B, or D is equal to Q1 in the D-FlipFlop. So those kind of examples like assignments will be declared in the procedural blocks. That means inside the initial and always blocks. If the procedural blocks are executed in parallel, so for example, while we are writing bigger codes. You are adding multiplexer code in the top down approach, not the bottom up approach or any other thing. You can consider bottom up approach as well. In those things, we are clubbing all the modules. For example, you can club 8 by 1 multiplexer. Inside 8 by 1 multiplexer, you can design 8 by 1 multiplexer with 4 by 1 and 2 by 1. So all these blocks, all these modules should be in one single Verilog HDL file. Then what will you do? All these modules should be executed parallelly. So in each of the module, like for example, if this is the module for 2 by 1 multiplexer, imagine there is module for mux 4 by 1. Got it? So in that module again we have always. So this is 1, this is 2. So this always block should work parallelly and this always block should also be executed parallelly. Then all these modules, so entire big Verilog HDL file. So in that all blocks, if all these blocks execute parallelly at the same point of time, at same point of clock, while we decide always at the rate pausage, I'll explain. I'll show you an example again. So at the same time, that is itself called concurrency. Remember this word again. Note down. When I say note down, note down. So you can add all these points as well. So this is concurrency. Very important. That is what we require for a faster execution of the program. That's what we look when we write hundreds or thousands of lines of Verilog HDL code. That should be executed within nanoseconds. So how do we design that execution? By parallel execution of the individual blocks. Those are procedural blocks. So what do we have in behavioral modeling? We have procedural blocks. What are procedural blocks? We have initial and always blocks. In the same way, if the procedural blocks are executed, means for one module and another module, if in the same module you have two procedural blocks, okay, that is also fine. I mean, two always blocks or three always blocks in one single code. Then itself, if all those always blocks, again procedural blocks are always block and initial block. So if these always blocks or initial blocks combinedly executed parallelly, then that is called concurrency. Then we need to consider LHS and RHS. What do you mean by LHS and RHS? For any operator, right? So as I said, output is equal to input. We are declaring. So this can be LHS, left hand side, and this is RHS for any relator or for any operator you have in this between. So all the LHS can be called as registers, reg. So that's what we declare, right? Reg 3 comma 0 3 colon 0 a. What is it? It is a vector. So and RHS is, RHS can be register or wire. So input, whatever sits here, that can be input. Sometimes inputs are whatever you give in the multiplexer or some logic cells or in the entire design. If you are designing an adder, if you give inputs, those are on the right hand side of these things. So if it is y, right, if you have a and b adder, so you can give some as a XOR b XOR carry in, right? So there is a carry in as well. So this can be an equation. So all these are inputs. We have seen the full adder implementation yesterday in the data flow modeling. So same in the behavioral modeling, this can be output. Okay, now don't get confused, this is why. remember this type of structure. So this is LHS and RHS, not based on the circuit, but based on the Verilog HDL description that we write. You will be better understanding when we show you the code. So that is what LHS and RHS is. Even for any binary operator, LHS and RHS are most important things that to be remembered. Okay guys, so coming to the next thing, we have spoke about concurrency, parallel execution of procedural blocks. Simple explanation, what is concurrency? Parallel execution of procedural blocks. What are procedural blocks? Those are nothing but input initialization, like initial block and always block. Blocks are nothing but, for example, you have a page of Verilog HDL code. In this, first thing will be initial block, and the second thing will be initial, and it starts from always block. So this is a main Verilog HDL code. Actually it will be main.v, but I have mentioned Verilog to make it understand. And earlier in the beginning of the training we used to do this with VHDL. Got it? So in this way you can see initial and always. Then okay, we are talking about concurrency. So in the same way, in the Verilog HDL file, if the concurrency, for the concurrency, parallel execution of the procedural block statements is called concurrency. And one type of error to note while applying the concurrency. So as I said, there can be more than one always blocks, and there can be another always as well. In the same way, you can have many always blocks and one initial block. This is executed only once, but this can be executed several times. So like this, the mistake, the syntax mistake you shouldn't be doing, or you should be taking care of, is whatever the inputs you use in one always block shouldn't be used in the second always block. Likewise, if you use them in the initial block and you use them in the always block, fine. But if you use the same variables, same elements, same names in the same second always block, Verilog HDL will be getting confused. So it will be executed in a sequence, and then when coming to this point, it will be getting an error. So what is the error? Earlier it said a is equal to 0, b is equal to 0, but now it is saying a is equal to x plus y and b is equal to x minus y. So does it consider this or this? It will be confused. Then if you name it as a1 and b1, problem will be solved, because whatever the functionality x plus y and x minus y, those can be stored in different variables, not in the same variables. Understood guys? So that error you should be eliminating. So in the LHS of both initial and always block should be different. That's what it says. So if it in the initial block, okay, it starts from here, and always block, it begins from here, and for all these things you need to end at one point, that is end. So this is a sample program. I have just given an example of it. So you can see these type of always blocks. You can write n number of always blocks for bigger circuit and bigger codes. We do write it, and there are some simple ways to represent it in a easier way to understand. Then coming to the other attributes, we have blocking assignment statements and non-blocking assignment statements as well. So what are blocking and non-blocking assignment statements? These are internal of the always block. So blocking is represented with equal to, and non-blocking will be represented with less than or equal to symbol. You can see that can be shown with one of the examples. Blocking statements executed step by step. So whenever you can see these blocking statements here, those are executed step by step in a sequence. But in the non-blocking statements, you can see these are executed parallelly. Whatever it executes parallelly. For example, if Z1 is equal to A, then it in this point Z3 is don't care. Z3 is don't care. Z3 can be anything, 1 or 0 or 0 or A or any other thing. So Z2 is equal to Z1 A plus B. So it is considered parallel, and then Z3 is Z2. Now it takes from Z2. It doesn't depend on any other value, so it is executed parallelly. You will be understanding this when we run a simulation program in the project. So Z S1 are equal to Z1 plus Z2. So these are executed parallel. Takes very less time to execute the program when these lines are executed parallelly, not one after the other. So for example, if Z1 is equal to A will be assigned to Z1, then after it will go to Z2, and then after Z2 is done, it will go to Z3, and Z3 will go to the if it is taken, Z3 will be considered in the last after 25 nanoseconds. So the time frame will be, first it will be at 0th nanosecond, but after 10 nanoseconds it will be taking this, and then after another time after execution of this 10 nanoseconds, at after 15th nanosecond it will be like 35 nanoseconds. But here, so 10 plus 25, right, it is 35 nanoseconds directly. But in the non-blocking assignment statements, at the 10th nanosecond you will be seeing this data, and after 25th nanosecond you will be seeing this Z is equal to Z1 plus 2. So all the time taken is by the completion of the 25th nanosecond you will see the output. So we have 10 minutes grace time. So that is the advantage of non-blocking assignment statements. So if you want to execute parallelly, this is how you should be writing. And simple explanation, you can see while writing behavioral coding, right, behavioral model, this Verilog HDL in behavioral modeling, you consider first step as module name, second step as input and output, third step is output, wires and registers, and fourth step is always continue, fifth step is to begin, and this end is also nothing but related to fifth step. So sixth step is nothing but process. This is the process that begins. You are declaring whether this process should be in blocking assignment like equal to, or non-blocking assignment. The major difference is in blocking assignment, until this line, the first line gets executed or completed, it won't go to the second line of execution. Until the second line is getting completed, it won't go to the third line and fourth line. In the same way, it is a sequence, but in the non-blocking statements it will be assigned, these things will be assigned and completed parallelly. All these things will be parallel. So whatever the Z2 is, it only depends on Z1 A and B, but not in a sequence. It will be waiting here. So if you have A here, and if you declare B value somewhere and it considers it here, it won't wait for Z1 to be executed. Hence the reason by after 25 nanoseconds, whatever time we declare, it should be completed by that time. We are controlling it here. So that is major advantage. Don't get confused, guys. Simple hack. In nowadays we are using only non-blocking. Blocking assignment statements will be used in some of the lines, but Assignment statements. This is a statement. This is again another statement. This is statement and this is a statement. So these are the statements inside process. When you begin the process, you need to end the process. That is fifth point. And you need to end the module which is related to 6. I have mentioned these 1, 2, 3 as the comments. This way you can comment these things. So if you comment, then it will be understood very well, these parts. So did I miss anything? Executed parallelly. Every statement is executed parallelly. The answers or values will be assigned parallelly. Highly operated and used. Remember these 2 points. Then symbol will be less than and equal to. So 1 second guys. And coming to the comparison, you can see I have given the comparison again in the same way. This is just to make you feel better after with the same individual slides. You can look into these things and then you can understand how these are written. Okay, so pause it here and understand. Okay, because of the assignment statements, this works in fast. So coming to the advantages of behavioral modeling assignment statements. Concurrency is possible. That means parallel execution of procedural blocks. This concurrency is possible. And if you can see these always blocks, if you write these assignment statements here, so with that assignment statements, this will be executed at 1 second, at different nanoseconds, different times. This will be executed, or all at once it can be executed, but not in a sequence. If it goes with sequence, imagine you have 1,000 blocks, 1,000 always blocks. What happens? It takes more time, but all the blocks you write in the always, it should be written parallelly. Written is written, this written, not coming back like feedback written. Not this written, this written. So you should write in assignment statements. That would be the advantage. So concurrency is possible and race condition can be avoided. Race condition is like sometimes there will be internal blockage with the race condition, like the loop will be executed these many times, and those kind of race conditions like data issues, that race condition can be avoided and eliminated. The other advantage is swapping of data between the same variables. For example, if A is equal to B and B is equal to C, now C can be A. So that is how whatever variable data you have in A, you can write it in C. Understood? Write it in C. So these are the advantages, hence speed of execution is possible because of parallel execution. And then coming to the example of behavioral modeling, another example, pipelining is one kind of important implementation using blocking and also using non-blocking. Pipelining, understand pipelining. Some better examples with D-FlipFlop, and in the pipelining of 2 D-FlipFlops, understand module block. You need to mention some block. I'm mentioning name as block and input as D, clock, and outputs will be Q1 and Q2. So input D and clock, outputs Q1 and Q2, registers Q1 and Q2. Why don't we mention square brackets and size of the registers, size of the outputs? Because flip-flops output can be declared as by default as 1 here in this example, not to confuse you many times. But when you write register, it is good to write single bit. If it is single bit, leave it as it is by default. So registers, all outputs are registers, so this can be register whatever comes from the output that can be registered. So this is Q1 and Q2 inputs, D and clock. So based on the clock high value, this will be enabled. So based on the same high value. Now Q1, so step by step, this is first step, this is second step, register is third step, always is fourth step, and begin and end is the fifth step. The functionality written output input equal to, this is blocking, I mean with the blocking assignment statements. So we have written equal to, so D is equal to Q, D is equal to Q. One second guys. I can explain better with timing examples as well. So yeah, now you can see we have written here with Q1 is equal to D, and yeah, blocking I will represent with red symbols, and Q1 is equal to D and Q2 is equal to Q1. So what it explains, it is executed step by step. Blocking statements will be executed step by step. Only if Q1 is equal to D, whatever the value in D according to clock, value will be Q1, then it will be considered Q1 is equal to Q2. Got it? So hence Q2 will follow Q1 and an end module. Got it? Then you can see this is Q2 and Q1 and data is D. How this data transition will occur? We have clock for every 10 nanosecond. For example, this is a 20 nanosecond clock. Imagine the period is this, it's a 20 nanoseconds clock. That means what is the frequency? Just let me know. If you follow this along, you have time period of 29 seconds. What is the frequency of operation? Calculate and tell. I will not be telling this because it's a basic operation in megahertz. Okay, so in this clock period the data transmission will be followed. So D flip flop, this some random value it has come, and 0, and again enable. How do we get Q1? So Q1 is followed for every passage of the clock after the period of time. For every passage of the clock, it will be checked, it will be verified. Remember, this is passage when the clock is rising, that is called passage of the clock. Okay, at this passage of the clock, first data, the value of D is 1. So till the next transition, the data will be 1 of the Q. So this is 1. Okay, now understand, for the next transition, for this transition at this next passage, what is the value of D? It is 0. Got it? So it is 0. In this way, now Q will be following D. Q1 will be following. So Q1 will be this one. This is Q1 and Q1 is followed, and Q1 is followed, and then how do we get the Q1? By this way. So at this point of time in the clock, in this clock, the value of D is 0. Again it shifts to 0. But next it should check for the next clock edge, right? Let us take this clock edge, this positive edge. What is the transition of D value? There is no transition, it is 0 again. So it is 0 again. So the value will be 0 for the Q1 till the next clock edge. Okay, till here. Then go to the next thing. In this passage here of the clock, you can see the D value will be 0 again. Hence, the D value Q1 will be 0 again. But at this passage, what is the value of D? It is 1. Hence, Q1 will be 1. The value changes from this 90th nanosecond. So, Q1 will be 1. And at the next passage, till the next passage, Q will be the same. So, come back to the next color. So, what is the next passage? The next passage will be 1 at 1/10th nanosecond. Likewise, you can get at D value is 0. So, hence Q should be changing from 0. So on. I'm just giving a sample, guys. Now in the blocking equal to assignment symbol, Q2 will be exactly same as Q1. It is related to the D as it is, but it will be synchronized with D and Q. It is not left alone. Q2 will be following whatever D values. It will be getting the Q as it is. So that's what execution is called. So D values will be coming here, and now Q1 is stored. And what are the values you are getting here? D values. Okay. So now the Q2 will also be the considering the same values. Got it? So this is it. In the same way, if we can take non-blocking, using non-blocking, it is a parallel execution. So it is in a parallel execution. Q2 will not be depending on the D. It depends on the input of the input of the second flip-flop. So what is the change? Everything is same. The module name, input, output, register. So this is the second step, the first step, third step, fourth step, and this is the fifth step, and functionality is sixth step and seventh. Whenever you write Verilog HDL for these simpler things, write it from in this way. You write it in this format. Start from module and end at the module. Input and output declaration, registers, always block, always at the right passage. If you can see, we have introduced clock here. So for every always at the right passage, check the value of input. Data changes. When data changes, the output will also be changing. So now understand, value of Q1 is given with D. At the same time, Q2 will be taking the values of Q1. So these will be executed parallelly. While they are executing parallelly, there is one bit of a thing where the execution will occur parallelly in this way. There will be slight difference when it dips from here, and that slight difference will be considered in this way. For example, the slight difference will be, see here it is slight difference. So it can be like 0.00011, it goes to 1 in this way, slight slanting difference. But with that difference, it considers the previous value of Q1. So Q2 will be 0. And by the time Q1 is equal to 1, and that 1, it will be slightly slantingly descending, and that fall time will be in this way. So that is 1, a little bit. This is the gap. So we have the value of 1 still. So that value will be considered by the Q2 and it will be taken as 1 for the next clock cycle as well. It will only change while the D is changing. So while D is changing, the Q will be affecting according to it, and when Q is changing and Q is getting transitioned at the clock time, it will be considered as it is not depending on D. It is only considered with Q1. Just think of it that way, so that when Q changes, from 0 to 1 again, there will be slight value of 0. Hence, the value will be falling to 0. Parallel execution, right? There will be fraction of seconds. Some fraction of seconds. Hence, again the value here, it will be 1, right? Wherever the Q1 changes, it will be 1. Some fraction, it tends to 0 here. Then, but the previous value is 1. It understands by this transition, it is 1. So, hence it is 1. This is how Q2 will only be depending on Q1 parallelly, and Q1 will be depending on Q1 will be depending on D parallelly. Same, there will be no issue, but the data will not be lost, and it is same as it is. Got it, guys? So it is about non-blocking assignments, and then we can go with if else and case statements in the next class. I will try to give you some interview preparation tips now, because all the loop conditions and case conditions, if we explain in a simple class, it will be better understood. So I'll introduce you to the if else, case, forever loop, for loop, while loop, and repeat statements. All these loops I will introduce in next day of the training. But today let us go to the interview preparation tips. First thing, personality traits. I want you to make a note of these things. What habits you should have, or what personality traits you should be having. Commitment towards the accomplishments. For example, if you take a single task for next 2 hours or 3 hours for the short term goal, take the task, complete it, and then shift on to the next task, so that you will be boosting up your confidence. If you want to prepare something for some exams, or some for projects, or you want to learn some skill, dedicate your time for this amount of time. Usually for every 25 to 30 minutes you can take 5 minutes of break. That would be ideal to work every single task. In the same way, you can focus on what to do every day. Consistent efforts. Focus on what to do every day means daily keep a diary. From today onwards, keep a diary and write down the tasks that you need to complete and accomplish them by the end of the day. For example, take it in a practical scenario. You will be only having 4 or 5 different tasks, but you can only complete 1 or 2. Don't worry, one day you will complete all of them. You will be learning time management with that thing. So when you write all those tasks to be completed, and if you complete only 50% of it out of 100, like if you have 4 tasks and if you complete only 2, remember these 2 tasks and complete them tomorrow. And if you have spare time, complete the 2 tasks as well. By the end of the day, you will be feeling you have accomplished something. In the same way, every day choose for 1% increase in your growth as per career or as per happiness. So why do we need all these personality traits? Ultimate thing is, I want you to be happy. Happiness. How do we achieve happiness? We achieve happiness through good job, good profile, good amount of earning of money, taking care of our loved ones like parents or any relation that you have, and enjoying your own time. When can you enjoy? When you are learning all these things. So this is one kind of entertainment to you. You take it as an enjoyment. Enjoy the learning. That's why I say happy learning in the end. So enjoy the learning. Then after you can accomplish whatever task you encounter in the next day. So that is how you can focus on what to do. So that's how I start the training from today's agenda. In the same way, you need to declare what is today's agenda. This is only 1 hour class, and consistent efforts. I mean, whatever you do, you don't stop. There will be some hiccups. I mean, there will be some stoppages and break points, but again you need to restart it. That's what the consistency is. Consistency is nothing but start, have something done, you will get some break. It's a nature's pause. You have a pause, and then start it from again, wherever you have left this point, from this point, and reach to the end. That's it. It is simple. The consistency is means at least you need to do the same set of tasks for at least 20 minutes of time, half an hour of a time. If you are doing one task for 1 hour or 2 hours every day, learning this training every day, then you need to complete at least uh, half an hour or 20 minutes of the training today, if you can't do any other things. And consistent efforts. I want you to have a time management and routine schedule. If you are going to college or office, take the time out and split the remaining time into your relaxation and into your preparation things. And result oriented working. The next thing is result oriented. It's nothing but whatever you do, if you have done the work for 30 minutes, if you are taking 5 minutes of break, think about what is the result that you have acquired. If you didn't acquire result, okay, after 1 hour you will get, or after a day you will get to see some results, or after 1 month you will get to see some results. But in that 1 month period of time, every single task will be uh, an accomplishment. That accomplishment is a result of that day. And what you need to have, you should have short term goal and long term goals. In terms of interview and job search, I will explain this in the next section as well. Goal setting is an important thing. That's what I am asking you to do every day. You should set what are the goals today. I mean, what are the targets today to complete, and what targets to be accomplished in the later part of the day. Then acquiring relevant and most essential skills in your personality. So now you are acquiring FPGA development and understanding of FPGA development EDA tools in Xilinx, and now you are also understanding Verilog HDL. In this way, develop your own skills. I can introduce you to the different programs that out of my industrial experience. In the same way, you can do them. You can have these relevant essential skills from the internet. Nowadays we are lucky that we have internet and we are accessing global level knowledge from renowned universities as well. So acquiring relevant and most essential skills. Relevant is like compulsory for one job, for one specific job. Most essential are nothing but common for every kind of job. For example, in every fresher related jobs they will be asking for C programming or Python programming. Very simple. So you need to do those kind of things. So acquiring them is a must. Hence, these are the today points that I want to discuss with you. I'll be giving some examples when I take some interview preparation classes, right? That will be intense, and you will be understanding lot many things out of interview preparations. So better understand this and do follow with these things. Then coming to the reference textbooks, some of you have asked, and I have found these two as well known things that I have studied in my earlier days after engineering to understand VLSA. Then first book is Design of Analog CMOS Integrated Circuits by Behzad Razavi, and CMOS Circuit Design Layout Simulation by Jacob Baker. You will be understanding about IC designs and circuits. Mostly analog is nothing but IC design, standard cells. For example, if you are designing AND gate, inside AND gate you need to design AND gate with CMOS transistors. We used to design NAND gate with CMOS transistors, PMOS and NMOS connections. So at the IC levels, how do you do that, and how do you use that NAND gate in the bigger circuit? So at the end of the day, inside deep down the circuit, in deep down the IC, you are dealing with transistors. Okay, so CMOS transistors. So these two books will be good if you are in college. Search for these books in the library, go through it. I don't want you to complete this in as a semester, but go through them, understand the topics from the beginning, write down few points that you will be way ahead of all other people. So that's another advantage. So that's it, I think. Uh, we can meet in the next class. So this is the FPGA. By the signing off, whatever you do behavioral modeling, that you will be declaring all these pins, inputs, outputs, and logic function, display, and all these things, and then you can be working on the FPGA. In this way you need to flash the program. So that is how you understand behavioral modeling. There is a continuation in the next class, so stay tuned. So if you have any questions, just um, ask me in the same regular way. How do you ask questions in WhatsApp chat? And I have also enabled first introduction classes to install the EDA tools and all. So for the next 2 days, and I'll be limiting the access of these videos very soon. And yeah, if you have any questions, just let me know and I'll be answering. So thank you guys. Have a good day.